ignoring all the stream-based delegates and the participants. This is the 9th day of Jam Sustainable Urban. And I hope all of you are enjoying it. Yesterday we learned about water, water systems, and today we are going to learn about something related to water stress.
Very good, very good.
Smart guy, right?
Smart, yeah. I just put the thing there because we're going to talk about something related to water. And it's this. That's right. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 14. So 14 hardcore people are here. Okay, you guys are awesome. Okay, thanks for showing up. Showing up at around 10:30. So, shall we start talking about this? About sewage? And I want to get to, maybe if time allows, I want to get to solid waste also. So tomorrow we'll have, today is supposed to be solid waste, okay, but we haven't covered this from yesterday and this is really important. And then tomorrow we'll have for buildings and climate change, cities and climate change. And both Professor Mandla and I want to have a discussion with you guys, architects and urban planners, how architects and urban planners can be more involved. Okay? Okay, so before I get into sewage, I just wanted to remind you once again some of the water issues. Some places are going to have very high water stress. India is going to be one of them. And there's a big need for safe, affordable, clean drinking water for cities. And in India, it's a big problem, right? So you'll have lots of opportunity to solve these problems. So sanitation and sewage is also a big problem. And I'll tell you a couple of stories today, and also I'll share a couple of videos with you today on sanitation and sewage. And sanitation is not just about toilets, but it's really important that toilets are there. And there are 2.4 billion people worldwide who do not have access to decent sanitation systems. 2.4 billion people. And about a billion people, about 1/7 of the world's population, engages in open defecation. Since the number used to be much higher. Number used to be almost half the world's population. It used to be about 3.4 billion 30 years ago. At that time, the world population was less than 6 billion, and 3.4 billion did not have access to sanitation in 1990. But since then, 2.6 billion people have gained access to sanitation. Most of the gain has happened in China and Bangladesh and Pakistan. Okay, those are the places where people have really gained access to sanitation. 5 countries account for the global 75% of the open defecation in the world. And the largest number of people in the world that engage in open defecation, probably over 500, 600 million, is in India. And the government has made lots of, Indian government has made lots of strides in the last few years, but still there's a very, very large number that still engages in open defecation. And while the government programs are there, it's really cities and states have to engage in measures to decrease open defecation. That's when things change. So I'll share an example of how in the city of Indore, they reduced open defecation. So the city of Indore, as you know, from 2016, it really made, I'll talk more about this later, made a big move towards managing its solid waste and became the #1 cleanest city in India by 2018 or 2019. Largely because of the initiative of the then municipal commissioner of Indore. So he then got transferred out and the new municipal commissioner came. And he said, I am going to continue the solid waste initiative, but I want to do something myself as well, in addition to solid waste. And he decided to focus on open defecation, to remove open defecation in Indore. And he went and spoke to the elected leader, the mayor of Indore, who had recently been elected, who had no history of political action, but was elected because her husband, who was running for mayor, got shot and died 2 weeks before the election. So her husband was still on the ballot. He got elected, and they made his wife the mayor. So she became the mayor, and she said, I want to do something about open defecation. So first they asked planners to map where people are defecating. So planners went around and figured out where open defecation is happening. And then they asked planners to identify places where good quality community toilets can be built. Then they asked planners to identify where good non-profits could manage those community toilets for a very small price. Okay, if it's free, it never works, okay? So it won't be maintained, government does not have the money, so they identified some non-profits to manage that. And then after these things had been working for some time, 1 or 2, 3, 4 months, then they started mapping where people are still defecating in the open. Okay. And then once they identified where the spots people are still defecating in the open, even after having access to community toilets, this is what the mayor and the municipal commissioner and the police commissioner of the city decided to do. Every morning at 5 o'clock, they would go to one of the spots where people open defecate. And suddenly when people are open defecating, the mayor and the municipal commissioner and the police commissioner show up when people are open defecating. And they would talk to these people and say, don't do it. Okay? And so it requires a lot of courage for the mayor to do that, for the municipal commissioner to do that. And over time, they repeatedly went to these sites where people were, in spite of having access to good, well-managed community toilets, were open defecating. Mayor is the lead. Mayor is the lead. Yeah. Current IE is also lead. But when this initiative was done, the municipal commissioner was a guy named Ashish Singh. And like this Ashish Singh, Ashish Kumar, right? Sorry? Yeah, okay. But same name, same first name, Ashish. And they really made a big change in making indoor open defecation free. Okay, when I visited Indore and spent time there, I was there for 3 or 4 weeks. Talking to everyone, even average persons were saying that they have access to toilets, and most people were not. There were no visible signs of open defecation in the city. So it's Indore says there's no open defecation, and I kind of believe Indore when they say that there's no open defecation. That was my first. I spent that was my first time and only time. I haven't gone back since. But I walked. I talked to a lot of people, met everyone, spent a long time with me, and spent a long time without any officials with me. Just roaming around the city without anyone. So I saw parts of the city that officials would have taken me to. Now I'm going to show you a TED Talk if I can bring this up. But before this TED Talk, I'm going to tell you 2 stories about human waste. One from Paris and the other from London. Actually, I'll tell you the Paris story, and the London story maybe we'll do just that TED Talk. In the 1840s, 1850s, in Paris, they had a water supply system managed by private entities. In Paris, there's a big river that flows to the city. The name of the river is Seine. Seine, pronounced Seine. It's a big river, and people in Paris, people in France, really, just like The Seine River is to people in Paris and France like the Ganga is to people in Patna in India. Okay? They really think highly of the river, everything the river is great, and so on and so on. So, Paris in the 1840s had about 70 to 80% of the urban population of the country. And maybe about 50%, 60% of the population, 50 or 60% of the total population of the country. Okay, so a lot of people in France actually lived in Paris, and many places were high density developments. So there were private water companies that had horse-drawn carts where they had wooden barrels. And every morning they'll go to the Seine River, fill those barrels with water, and then come to all the city streets and sell the water. So then people will buy the Seine water from these private entrepreneurs who were selling this water. So that's how most people in Paris, if they had money to pay for this water, that's how they got their water. Some people had small wells at home, they won't get good quality water there. And so whoever could afford it, and many people, so about 70 to 80% of Paris' population was buying the Seine water in India. Paris also had a municipal, human waste disposal method. All the human waste was collected and put in a pit near the front boundary of the house. Okay, it was put in a pit in the front boundary of the house, and if the boundary was a stone boundary, there was a gate in the boundary where this pit was. And every late night, early morning, some people would come. They would open this gate, take all this human waste, and these people had different horse-drawn carriages with different wooden boxes. And they would put all this human waste, which was called night soil. They would take all this human waste, put it into these wooden boxes, put it into their horse-drawn carriages, and they would take it away from the houses. And they would dispose it by putting it in the Seine River. Okay? So, almost every 2 or 3 years, there would be a outbreak of cholera in Paris, especially in the 1820s to 1840s or so. Every 2 or 3 years, outbreak of cholera. And people didn't know what's causing it. People didn't know who would get it. They don't know, they don't know how it was transmitted. They didn't know what it was causing. So as soon as it happened, lots of people would die. Like within a month, about 1 in 20, like 5% of the population would die. Okay, as soon as this disease starts spreading, what would happen is most of the people would try to leave the city. And when that happens, the city, it was ruled by kings, right? So when the people in the city leave, there's less people to defend the city. And people are unhappy also, and people are dying also. So, but for the emperor, the concern was if there's an attack, there's not enough people to defend the city. So the French emperor then asked his prime minister, a guy named Baron von Haussmann, to solve this problem. Okay, Baron von Haussmann did lots of other things. Okay, he's a very important guy for architects and urban designers. Before his intervention, Paris was just a collection of streets. Something maybe like parts of old Patna. Okay, it was not very beautiful. And he came and demolished areas, made streets. So he did a whole bunch of things. So urban design was very important. But anyway, Baron von Haussmann was told that he's got to fix this problem. So he started looking around and said, what could be the problem? And he started going to different neighborhoods on horseback, trying to figure out like where are the last time cholera happened, where did the deaths happen? Which areas did the deaths happen? And he started forming an idea of where the deaths happened. And then he realized that in northeastern Paris, certain parts of northeastern Paris, people were very, very poor they were not buying the Seine water. Okay. Instead, they were getting water. Now there is a mountain range called the Alps in France, and it is always snow covered, and in summer there is melting ice that comes. 2000 years ago, France was under the Roman Empire, and the Romans had built huge aqueducts, lots of aqueducts everywhere. And they had built aqueducts that would bring water from the Alps to some of the areas in Paris. So these poor people who could not afford the Seine water, they were actually taking this free water that was coming down from the Alps. Okay, and Baron, the husband figured out that these people who are not drinking Seine water are not getting the disease, when people who are drinking the Seine water are getting the disease. So he said, we got to do something about it. So he first built a system of canals, some overground, some underground, that would take this Alps water and bring it to many parts of Paris. And in many places, he created public squares, plazas, and created fountains. Okay? And this Alps water, through the aqueducts, started coming to many places. After he built this infrastructure, he issued a proclamation. So the king issued a proclamation that no one is allowed to drink Seine water. So first, he did some analysis. Then he created the infrastructure for an alternate system. So if you go to Paris, you'll see lots of fountains and all that, public fountains. They are not for aesthetics. They are beautiful. They now function for aesthetics, but they were purely a public health intervention. So people could come there and get this free water. And so the king issued a proclamation. Adrish, we were waiting for you. Now we wanted to take a photograph of all the hardcore people, but since you hadn't come, we couldn't go.
He called me.
He told you?
Yeah.
Okay. So we postponed the photo shoot. So they just to accommodate. So anyway, and then the king issued this proclamation that no one could drink Seine water. And the people in Paris were really upset. They almost revolted against the emperor, because they believed that Seine water was really unique. It had something magical. It had this wonderful smell and taste that this Alps water did not have. Okay? But the cholera outbreak was just breaking when that proclamation came. And as soon as the proclamation came and people started drinking this Alps water, cholera stopped. And people were convinced that there's something bad in the Seine water. They didn't know what it was, but they stopped drinking Seine water. And that was the last time there was a cholera outbreak in Paris. Okay? And that was the beginning of municipal water supply anywhere in the world. So it's very recent, and was prompted by human waste in drinking water. Very recent. I mean, the history of civilization is a very recent thing, 150 years ago. Now the other story is from London, and I will let him do the story. Okay. Let's see if this will come on. If it doesn't. Ashish might be needed for the sound, but let's hope it works well.
The world's population is increasing. Arable land is diminishing. We need solutions to produce more with less.
If you haven't ordered yet, I generally find the rigatoni with the spicy tomato sauce goes best with diseases of the small intestine. So sorry, it just feels like I should be doing stand-up up here because of this time. No, what I want to do is take you back to 1854 in London for the next few minutes, and tell the story in brief of this outbreak, which in many ways I think helped create the world that we live in today, and particularly the kind of city that we live in today. This period in 1854, in the middle part of the 19th century in London's history, is incredibly interesting for a number of reasons. But I think the most important one is that London was a city of 2.5 million people, and it was the largest city that on the face of the planet at that point. But it was also the largest city that had ever been built. And so the Victorians were trying to kind of live through and simultaneously invent a whole new scale of living, the scale of living that we now call metropolitan living. And it was in many ways, at this point in the mid-1850s, a complete disaster. They were basically a city living with a modern kind of industrial metropolis with an Elizabethan public infrastructure. So people, for instance, just to gross you out for a second, had cesspools of human waste in their basement, like 1 foot to 2 feet deep. They would just kind of throw the buckets down there and hope that it would somehow go away. And of course, it never really would go away. And all of this stuff basically had accumulated to a point where the city was incredibly offensive to just walk around in. It was an amazingly smelly city, not just because of the cesspools, but also the sheer number of livestock in the city would shock people, not just the horses, but people had cows in their attics that they would use for milk that they would kind of hoist up there and keep them in the attic until literally their milk went out and they died, and then they would kind of drag them off to the bone boilers down the street. So you would just walk around London at this point and just be overwhelmed with this stench. And what ended up happening is that an entire kind of emerging public health system became convinced that it was the smell that was killing everybody, that was creating these diseases that would kind of wipe through the city every 3 or 4 years. And cholera was really the great killer of this period. It arrived in London in 1832, and every 4 or 5 years another epidemic would take 10,000, 20,000 people in London and throughout the UK. And so the authorities became convinced that this smell was this problem. We had to get rid of the smell. And so, in fact, they concocted a couple of early, kind of founding public health interventions in the system of the city, one of which was called the Nuisances Act, which they got everybody, as far as they could, to empty out their cesspools and just pour all that waste into the river. Because if we get it out of the streets, it'll smell much better. And, oh, right, we drink from the river. So what ended up happening, actually, is they ended up increasing the outbreaks of cholera because, as we now know, cholera is actually in the water. It's a waterborne disease, not something that's in the air. It's not something you smell or inhale. It's something you ingest. And so one of the founding moments of kind of public health in the 19th century effectively poisoned the water supply of London much more effectively than any modern-day bioterrorist could have ever dreamed of doing. So this was kind of the state of London in 1854. And in the middle of all this kind of carnage and offensive conditions, and in the midst of all this kind of scientific confusion about what was actually killing people, there was a very talented, classic 19th century multidisciplinarian named John Snow, who was a local doctor in Soho, London, who had been arguing for about 4 or 5 years that cholera was in fact a waterborne disease, and had basically convinced nobody of this. The public health authorities had largely ignored what he had to say. And he made the case in a number of papers and done a number of studies, but nothing had really kind of stuck. And part of what's so interesting about this story to me is in some ways it's a great case study in how cultural change happens, how a good idea eventually comes to win out over much worse ideas. And Snow labored for a long time with this great insight that everybody kind of ignored. And then on one day, August 28th of 1854, a young child, a 5-month-old girl whose first name we don't know, we know her only as Baby Lewis, somehow contracted cholera, came down with cholera at 40 Broad Street. You can't really see it in this map, but this is the map that becomes the central kind of focus in the second half of my book. So in the middle of Soho, in this working class neighborhood, this little girl becomes sick. And it turns out that the cesspool that they still continue to have, despite the Nuisances Act, bordered on an extremely popular water pump, local watering hole that was well known for the best water in all of Soho, that all the residents from Soho and the surrounding neighborhoods would go to. And so this little girl inadvertently ended up contaminating the water in this popular pump. And one of the most terrifying outbreaks in the history of England erupted about 2 or 3 days later. Literally 10% of the neighborhood died in 7 days. And much more would have died if people hadn't fled after the initial kind of outbreak kind of kicked in. So it was this incredibly terrifying event. You had these scenes of entire families dying over the course of 48 hours of cholera alone in their one-room apartments, in their little flats. Just an extraordinary, terrifying scene. Snow lived near there, heard about the outbreak, and in this amazing kind of act of courage went directly into the belly of the beast, because he thought an outbreak that concentrated could actually potentially end up convincing people that, in fact, the real menace of cholera was in the water supply and not in the air. He suspected an outbreak that concentrated would probably involve a single point source, one single thing that everybody was going to, because it didn't have the kind of the traditional slower path of kind of infections that you might expect. And so he went right in there and started interviewing people. He eventually enlisted the help kind of this amazing other figure who's kind of the other protagonist of the book, this guy Henry Whitehead, who was a local minister, who was not at all a man of science, but was incredibly socially connected. He knew everybody in the neighborhood. And he managed to track down, Whitehead did, many of the cases of people who had drunk water from the pump or hadn't drunk water from the pump. And eventually Snow made a map of the outbreak. He found increasingly that people who drank from the pump were getting sick, people who hadn't drank from the pump were not getting sick. And he thought about kind of representing that as a kind of a table of statistics of people living in different neighborhoods, people who hadn't, percentages of people who hadn't. But eventually he hit upon the idea that what he needed was something that you could see, something that would take, in a sense, a higher level view of all this activity that had been happening in the neighborhood. And so he created this map, which basically ended up representing all the deaths in the neighborhoods as black bars at each address. And you can see in this map, the pump right at the center of it, you can see that one of the residents down the way had about 15 people dead. And the map is actually a little bit bigger. As you get further and further away from the pump, the deaths begin to grow less and less frequent. And so you can see this kind of something poisonous kind of emanating out of this pump that you can see in a glance. And so with the help of this map and with the help of kind of more kind of evangelizing that he did over the next few years and that Whitehead did, eventually, actually, the authorities slowly started to come around. It took much longer than sometimes we like to think in this story. But by 1866, when the next big cholera outbreak came to London, the authorities had been convinced, in part because of this story, in part because of this map, that in fact the water was a problem. They had already started building the sewers in London, and they immediately went to this outbreak and they told everybody to start boiling their water. And that was the last time that London has seen a cholera outbreak since. So part of this story, I think, while it's a terrifying story, it's a very dark story, and it's a story that continues on in many of the developing cities of the world. It's also a story really that is fundamentally optimistic, which is to say that it's possible to solve these problems if we listen to reason, if we listen to the kind of wisdom of these kinds of maps, if we listen to people like Snow and Whitehead, if we listen to the locals who understand what's going on in these kinds of situations. And what it ended up doing is making the idea of large-scale metropolitan living a sustainable one. When people were looking at 10% of their neighborhoods dying in the space of 7 days, there was a widespread consensus that this couldn't go on, that people weren't meant to live in cities of 2.5 million people. But because of what Snow did, because of this map, because of the whole series of kind of reforms that happened in the wake of this map, we now take for granted that cities of 10 million people, cities like this one, are in fact sustainable things. We don't worry that New York City is going to collapse in on itself quite the way that Rome did and be 10% of its size in 100 years or 200 years. And so that, in a way, is the ultimate legacy of this map. It's a map of deaths that ended up creating a whole new way of life, the life that we're enjoying here today. Thank you.
The word operation is increasing arable land distribution. We need solutions to produce more.
Okay, so cholera and the lack of sewage systems was a major threat to cities. And people believed at some point that, 1850s, 1860s, that people were not meant to be living in large areas. People should be living in dispersed low density locations. And fortunately, they came up with a solution. So you see what is happening in two cities. In Paris, they came up with a municipal water supply system. They still were throwing their sewage into the Seine. In London, they came up with a municipal sewage system. They still were getting their water from hand pumps and other places. And it's only by late 1890s, early 1900s that cities started putting these things together. They started putting sewage systems, they started putting water supply systems. So if you look around in Patna, maybe the first water supply system was probably put there in 1920s or 1930s or something. 1930s. And New York had its first water supply system around 1900. Okay, so all these things were coming to India almost at the same time as they were happening in other parts of the world. But other parts of the world, there's 100% water supply coverage, 100% sewage coverage. And India, there are a lot of challenges, primarily the pace of urbanization. Okay, so the rapid pace of urbanization is a huge challenge. Okay. How important was this this waterborne sanitation system? So in the 1960s, early 1970s, a very influential magazine called Science has wide circulation in US and Europe, and many Nobel Prize winners and leading scientists write in that magazine. So the editors of Science magazine in the 1960s surveyed the readership. They asked the readership to tell us which is the most important innovation from the dawn of the Industrial Revolution. So 1750s to 1950s, 200 years. Which is the most important human invention, discovery or invention. Okay, and so there are many things, right? By that time, X-rays had been discovered and used. Penicillin had been discovered and used. Many chemical, aspirin, which is very common for aches and pains. So many things that people had discovered how the blood circulation works, right? All of that had been done. But the winner was waterborne sewage system. Because it takes all this waste from houses and takes it away and disposes it so people do not die. So TV was there, radio was there, color TV was there, radio was there. This was deemed to be much more important than color TV, radio, X-rays, atomic bomb, all those things. Okay. So yes, this is not a topic that you and I want to talk about, or like to talk about, but this is a really important topic for quality of life in cities. And had it not been solved, we would not be in cities. We would not be living in a city like Patna. We'd be living in small clusters in different parts of the countryside, and probably having a bigger negative impact on the environment. Many places in the U.S. The city on the right is Nashville. Major cholera outbreak in the 1870s, 1880s because of human waste. And now let me walk you through some different types of sanitation systems that you might be aware of. And if you're aware, then maybe I'm just boring you, but often we as planners don't think about these things. Okay? So I want to remind you of some of these things. Septic tanks. Many people are connected to septic tanks. They don't have a waterborne sanitation system. Human waste is taken to a tank in the ground. And in that tank, so this is where the human waste comes in. It is moved around a little bit, and there is bacteria in there, so it remains there for 1 or 2 days. The bacteria go to work on this. They convert some of that into gas. Some of that becomes insoluble and collects at the bottom as sludge. Some of it is floating on the top. And then some of the liquid, the clear liquid, goes past to another chamber. This is not a filter, but there are holes in there. It's a wall with some holes in it. And then it goes to this chamber. And then after a period of time, when most of the solid has dissolved, this stuff goes out. Now this, there could be a tap there to let it out, or it could be just an open thing, and is let out into a place called a leach field. When it is coming out into the leach field, it's generally liquid. There are no solids in it, but there are bacteria. And once this comes out of the leach field, there'll be gravel and mud, and the goal is to expose this liquid that is coming out to oxygen as much as possible. And when it is exposed to oxygen, it gets oxygenated and the bacteria generally die. So this area becomes very, this liquid has lots of nutrients. It's nutrient rich because human waste has lots of nutrients. And so all this then goes to increase the fertility of the ground there. Okay. The problem with this is it requires, a septic tank system is that requires some amount of land. Otherwise, you need some large amount of land to aerate the liquid that comes out. So when you live in high density situations, people are living in small houses, you don't have enough space for a septic tank, so it becomes a problem. But in rural areas, this can be a very good way of providing sanitation, rather than providing them STPs, sewage treatment plants. You don't need sewage treatment plants in rural areas. There's lots of open land. This is a fairly clean and good technique. Now, the one precaution that one has to take when you're providing septic tanks is to make sure that the leach field is away from where your well is. If you're living in a village and you're drawing water from the well, the leach field should be far away from the well. Otherwise, if there are times when there's too much of this liquid that is leaching out, sometimes the oxygenation might not be very effective. There might be some bacteria, and if this is very close to some groundwater source, it can go into the groundwater source, contaminate, and then when you draw water from the well, you will get some disease. Okay? So long as the separation is there, this is a very good technique. And this is a technique that can be used in parts of cities as well. One city that has started doing this now is the city of Nagpur, at the city level. In the new housing societies that are being built at the edge of the city, they are requiring that each society build a large septic tank like this. And that in the septic tank, most of the solids are removed, and then there is this liquid that comes out. Now in the society, the society, there will be open space, they can actually put the liquid there and it will actually go down. But the city in Nagpur has decided that this liquid that comes out, they will collect all that liquid and they are taking all that liquid, which might or might not have bacteria, and then supplying it to a thermal power plant. Okay? Thermal power plants use water. Right? They burn coal and heat water to generate steam that generates energy. Thermal power plants usually take water from a river. That river water is good for drinking, especially surface water is good for drinking. So Nagpur has decided that rather than have the thermal power plant take river water, they'll give them this sewage water. And thermal power plants can use sewage water. They don't need like bacteria-free water. So they use this water to generate electricity. And rather than building STPs, this is what they do. And this is a very, very good technique. In India, you cannot build STPs fast enough to accommodate the urban population. And the cost of building STPs is very, very high. The cost of maintaining STPs is very, very high. The infrastructure needed for STPs is very, very high. Wherever there are STPs, the entire city is connected, sewage from the entire city is connected, and it flows generally by gravity to the sewage treatment plant. Okay? Does not have an STP. River Ganga. Making all the fields very nutritious. Highly fertile.
So one is working done, partially one is working done at Anisabad, near Dev. And that STP is working and the STP is connected to Punpur river.
Yeah.
And Punpur river is further connected with Ganga and they are channelizing the whole.
Yeah. So all the waste from the STP is going to the river. Yeah. So STPs is not a,
That will already be in pipeline, I think. Very soon the STP is in function.
function.
Hopefully we'll see that
Yeah. But I think going forward, the city should really think through STPs. The centralized STP is not needed, and for a scale and at the pace at which India needs it, is just not possible. Okay, this might have been in Patna, they might be discussing this for 30 years, and it still hasn't, or maybe 10 years, still hasn't happened.
Decentralized would work here. Decentralized STP,
Yeah.
the common will work here, but
Yeah. And in the new housing societies, even if they don't take this water and take it to a thermal power plant, housing societies have enough land. So you can have a leach field like this and put it in there. And in a city, have a municipal water supply system. So even if the leach field is contaminating some things, the water is not coming from a well in the housing society. It's coming from a municipal water supply system. And a sewage treatment plant, the cost of a sewage treatment plant, building the infrastructure for an STP and the plant itself is much higher than a water supply system. And people will generally pay for a water supply system, people will generally not pay for a sewage system. Okay, you can tell people that, okay, you want clean water, pay some additional money for clean water. But pay some additional money for this, it's very difficult. Okay? So we need to reduce the cost of dealing with this sewage. Anyway, this is one way of doing it. The waterborne sanitation system that came up in London was there in many, many places, including, I believe, in the Indus Valley civilization. So many years ago, in India it was there, but for some mysterious reason it's gone. And 2000 years ago, the Romans had it. The Romans had a waterborne sewage system. They had public baths and public toilets. Houses generally did not have a toilet in the house. They did not have a bath in the house. Everyone bathed in a public bath and went to a common community toilet. All the stuff from the community toilet was connected and taken to places. There are large ducts that took all this human waste and took it to the outskirts of the city. So in the waterborne sanitation system, there are two kinds of water. So I'll just walk you through this waterborne sanitation system. Okay, let's look at the thing on the right. So human waste from the house is taken to some large, is taken to the water in a sewage treatment plant, and this distance could be many, many kilometers, 10, 12, 13, 14 kilometers. Okay, this distance from the house to this everything here is the sewage treatment plant. This is the house, and everything else is the sewage treatment plant. Okay, so this distance from the house to the sewage treatment plant could be 10, 12, 13, 14, 15 kilometers. Sewage is heavy, much heavier than water. And so therefore, almost all these systems is devised as gravity flow systems. All the sewage from the house is collected and goes down by gravity to the sewage treatment plant. Okay? Now suppose the house is here and the sewage treatment plant is here, 1 kilometer away. You need so much of pipe, right? And for gravity to work, it has to be at a gradient of maybe, the gradient has to be, when any of you are civil engineers? Okay, this has to have what's called self-cleansing velocity. So all the human waste has to flow by self-cleansing velocity. So it has to be a 10 to 15 degree slope from the horizontal. And there's so much of quantity. So 10 to 15 degree slope from the house here, 1 kilometer. How much has the pipe gone down? Maybe 4 or 5 feet. Suppose the treatment plant is 5 kilometers away. How far has the pipe gone down? 20 or 30 feet. And then if it's about 15 kilometers away, the pipe is 30-40 feet down. So laying the pipe becomes a huge problem. You got to dig down 30 feet. And when you put the pipe there will be soil on top of that after you cover the ditch. The pipe has to be strong enough to take the weight of earth on top of that. So these pipes have to be very, very strong. So you have to dig deep to put them in. The pipe has to be very, very strong. All of that increases the cost of the system. A water supply system, a small pipe, 2-inch pipe, 5 cm pipe can supply water for a lot of people. And it's a steel pipe, can supply, it can withstand some stress. But these pipes, even if they're generally not made of steel, concrete or other materials, they have to be really big, they have to be very strong, they have to be very deep. Now, often what cities do is when the depth becomes too much, rather than go deeper, they put a lift pump. So if the distance is 15 kilometers, maybe after 3 kilometers they put a lift pump. And so if you come here, pumped up, comes here, pumped up, comes here. But pumping this thing up, it's a lot of weight. So it uses a lot of energy to pump this thing up. Okay? And somehow it comes. So there's a lot of cost to this. Lots of land. So a lot of depth you need to put this water centralized STP system. And once it comes to the STP, there are sedimentation tanks where all the solids settle down. Then 2 or 3 different kinds of sedimentation tanks where the solids settle down. Then treatment, some kind of treatment, activated charcoal that takes away some of the smells, some kind of chemical stuff that is put in there, some more aeration. And the goal is to separate out the solids and make the liquid as bacterially neutral as possible, smell-wise as neutral as possible, as colorless as possible, and then take all the solids out. Okay, all the solid collects in all these different sedimentation tanks, the sludge, and at each part is taken out, and it makes for very good fertilizer. Okay, and the liquid then can be taken out, and if it is cleaned up nicely, can then be discharged into the nearest water body. Okay, and it is often done. So after all this treatment, if the liquid that is coming out, if it has certain characteristics, the suspended solids are less than, let's say, 1 part per million. If the bacterial activity, like one of the common bacteria that you have in water is E. coli, if the bacterial E. coli concentration is less than 10 parts per million liters, and turbidity is this, and so on and so forth, as long as it is within certain criteria, it can be sent out into the water supply, into a stream or a river. And streams and rivers can clean up the rest. People, if they take that, they won't really die because their concentration is very, very good. Okay, so many cities, though, I don't know how Patna is doing its STP system, but many cities in the world in the 1950s and 60s said, we have these pipes that are going down a 10-degree slope for self-cleansing velocity. Okay. So they said we also have rain events. We have rains, we sometimes have snow, and all that liquid is melting, and this is generally going on the roads, and we've set up a separate stormwater drainage system where it takes all of this stuff, when rains happen, all the rainwater is taken somewhere and led to a river or stream. So the streets are not waterlogged. So many cities in the global north have those kinds of systems, So in the 1950s, 1960s, civil engineers came up with an innovation. Innovation was this: combined stormwater and sewage. So the pipes that are taking human waste, they will now have lots of rainwater coming in. So therefore, the self-cleansing velocity will be achieved with lesser gradient. Instead of 15 degrees, because now there's more water, you can have it with 5 degrees. Which means you don't have to dig as deep. So the pipes don't have to be as strong because the earth weight after the pipes are laid is not so strong. So many cities put that in place. Okay? Which is good, but there's one problem. The problem is this. Huh? No, I mean fresh water is there. People have lots of water, so they were not worried about the rainwater mixing with this toilet, the sewage. They're not worried about that. But there is this other problem. Now you have all this rain stuff, yeah, right? The rainwater is getting mixed with human waste. It's reducing the slope needed. But what happens when it reaches the treatment plant? The amount of treatment capacity needed is significantly higher. Okay? So maybe for a city of 1 million population, you need a treatment plant with 1 million tons of sewage per day capacity. But then when you have a combined system, you don't have to dig deep. But whenever, the treatment plant itself has to be maybe a 10 million liters per day capacity or something to handle, not every day, but those 30, 40, 50 days when there'll be a rain event. And so some cities were okay with it, but now what's happening with climate change? There are more rain events, or there are, rather than having a little amount of rainfall over 3 months, you're having lots of rainfall on 6, 7, 8, 9, 10 days. You saw one of the slides that Professor Mandal showed, right? How this more erratic, bigger events. So in many cities in the global north, what's happening is the treatment when they have these combined sewer system, the treatment capacity, the treatment plants don't have the capacity to accommodate these peak events. So what happens when these peak events happen? When these peak events happen and the treatment STP's capacity is 5 million gallons, but on Friday, today it rains, on Thursday it rains, on Friday, there are 10 million gallons of stuff that has arrived at the STP. So what do these cities do? They open up the STP and let everything go without treatment. Okay? And it goes into the river or the stream or the ocean without any treatment, because it's much more than what the system can handle. And that pollutes rivers and causes lots of disease outbreaks. So now many cities in the global north are converting their combined systems into separate systems. Okay? So, I don't know how the STP in Patna has been set up and other places in India has been set up. But if they're setting up an STP, centralized STP, they should not set up combined systems. Should be separate systems. But ideally, they should not be setting up centralized STPs. Decentralized, maybe, not one STP for 1 million people, maybe one STP if they want for 10,000, 100,000 people. Or preferably, like Nagpur is doing, really no STP. Just having large septic tanks, because that system is actually very, very good. That system is very good. It is time tested and proven. It is as good as what an STP can do, the centralized municipal STP can do. It just has to be managed with a bit more care. A septic tank has to be managed with a bit more care than a large centralized STP. So that might be the way for countries that are urbanizing fast like India to provide sanitation services, a clean sanitation for large segments of the population. With the STP.
Because they wanted to make that city very easily step. So they have a lot of existing.
Yeah.
You should see that optimistically that what is very key. You can see a lot of things swimming around and all that. You can see very different
Okay.
But most of the cities are still studying hard.
And the investment needed is very high. And
capacity of Indian cities
is not there. And to get the land for putting all the pipes in there. And all the time the pipes are put in there, like, till the entire system is working. There'll be digging going on for 5-6 years.
Itself is a problem. Ordinance puts it as a problem.
Yeah.
Because big pipe going along the road and other things.
Essentially, Varanasi, the Prime Minister is the member of Parliament at Varanasi.
Yeah.
So there the investment problem is not there at all. Because if you want something to do there, anyone can.
Because of that, it's a lot of issues. That also depends on your representative is how powerful he or she is.
Yeah. So, and not every local politician can become the Prime Minister, right? So I think now many water supply, sanitation systems in the US are 70, 80 years old. So now cities in the US are also thinking, do we really invest in a centralized sanitation system, because they have to do some replacement soon. Should we replace the old system or should we come up with a different system? And I'm pretty sure they'll come up with a non-centralized, like maybe decentralized system, because that's much more easier. And they can probably go for what Nagpur is doing in the periphery. Have large septic tanks that will treat not just from one housing colony, but for 10,000 people, 20,000 people, a large septic tank at the edge, because US has lots of land, so I think that's what they will do. But this STP phase, I think, is going up. Okay, one centralized STP phase is going up.
What about in Europe? What they are doing? The cities are having
They should have they would be, but they have this dual system. But their infrastructure is also very old. So, at least 120 years old from London, Paris times. So I don't know how they're dealing with it. I haven't kept track of what they're dealing with it. But I really think that India should, if possible, skip over the centralized STP. Just like India skipped over landlines and telephones, right? 20 years ago, 5% of the population had telephones because landlines were not there, right? And I think I mentioned this right on first day. And now everyone, even in that small village in Udaipur, has got two cell phones. And putting landlines now is useless, right? So I think India has this opportunity to skip over this phase of one centralized STP or 2 or 3 STPs. Probably. It can go directly to some other method of... Now people need to have toilets, okay? And we need to provide community toilets or individual toilets and get people to start using the toilets, okay? So in these villages in Udaipur that I've been working on, there's been this campaign to provide toilets, right? And usually the village head, the sarpanch, gets money to distribute. And usually the village head, the sarpanch, makes a toilet. He makes the toilet very close to the entrance of the house. So if he has a compound wall, he's got a toilet there. And the toilet, even in the sarpanch's house in these villages, is generally not used as a toilet. It's used, it's put there. There is a toilet there, but it's either used as a storage room or used for some other purposes. Okay. So it is there. There is a toilet there. So in a lot of statistics, it will show sanitation has reached this village. It has reached this village, but even the sarpanch is going open defecating. Okay. But he's made the toilet because there will be some inspection, and he's got to show that there is a toilet there. So I've seen this in these villages that I have been to, 5-6 villages that I have. Yes.
You can have very good idea. I think involving students, bringing in here, that gives good ideas.
Yeah, and I brought students to Udaipur also. Yeah, we got Fulbright to give us money for bringing 16 students. We spent 1 month here. Yeah. In 2015, 2016, with about 15 students, 16 students, we came here. And we spent time in Udaipur, Jaipur, and Delhi.
So they were working.
Yeah. Now, if you don't have STPs, we can, septic tanks, then you can have pit latrines. Okay? Pit latrines will have a pit. The idea in a pit latrine is to concentrate and keep all the human waste in one place, and for bacteria to get to work and decompose that, and make it so that this human waste is not lying around everywhere. When people are defecating in the open, stuff is lying around everywhere, right? And so there's a possibility of germs getting spread by contact, humans coming in contact with fecal matter. But also, when all this fecal matter is just lying around in different places, when it rains, all this bacteria can then go to the groundwater and contaminate the groundwater. Whereas a pit latrine is not very sophisticated, but confines everything, and you locate the pit in such a way that it's far away from the groundwater. So it concentrates all the bad stuff, puts it in one place that does not contaminate the drinking water. So although a pit latrine is not very sophisticated, it still has a huge impact in reducing disease. And you could have like dual pits, like often a pit gets filled up, so then you shift to the second pit and use the second pit while this first pit stuff is decomposing. And after a period of time, this will become like good manure, take it out, and then you can put it onto the fields, and it's very good stuff. This is in El Salvador. On the left was what they used before, and then in that very same spot in the house, non-profits went and built a pit latrine, slightly elevated, so whenever it rains, the rainwater does not come into contact with the human waste, and it goes into a pit, so you have a dry spot when you're defecating. So that itself had a huge impact on reducing the diseases within that village. Having a toilet is one of the biggest, I think I mentioned this earlier, one of the biggest changes that can be made in rural areas in developing countries to increase female girl-child attendance in school. And having a clean bathroom is the biggest educational change one can have. I'm going to okay. I'm going to tell you something, and then I'll show you this. Show you this video. This video is from it's a TED talk with discussion about using toilets in India. Okay, one of the places that I go to with my students every year is this place called Institute for Social Innovation. It is an institute in Trivandrum, Kerala. It was founded and is operated by a blind German woman and her husband, a Dutch mechanical engineer. They wanted to set up an institute where young people who have a vision for changing the world could come and be trained in how to become social entrepreneurs. Okay? So they have this institute that they've set up in Trivandrum. It's been operating for about 15 or 20 years. Where every March or April they invite applications from people who are between the age of 18 and 30 from anywhere in the world. Okay? So there are many people who come there from Africa, from Nepal, from Bangladesh, from India. Many people come from all these places. And once they come there, they are trained to become social innovators and entrepreneurs. And they're given a lot of support and training in helping them achieve their dream when they go back. Okay, so they come here, get trained, go back. When they go back, for about 6 months to 1 year, they get financial support for their livelihood. Like for example, so they don't have, they'll get enough income so they don't have to worry about getting another job. They'll have enough income to get some office space, buy some computers, and they'll get a lot of support when they are gone back for about 1 year. But for about 6 months, they are trained here. So they've set up the center. And the center is set up using bricks, where they took soil from the site, made the bricks there, built the building with the bricks from soil on the site. They have solar panels that provide all the electricity for the place. But here's what they do with the toilets. The toilet that they have is a very, very high-end toilet. Like they have like 6 or 7 toilets, maybe 10 toilets. But each toilet, the toilet seat, is a particular brand name called EcoSan toilet. This toilet separates the solid human waste from liquid human waste, right there in the toilet, and takes it separately. Okay. The liquid human waste is taken through a special tube, taken outside into a system of pipes that are open to the atmosphere. Okay. So here, liquid human waste, urine, it smells because of bacteria, and that bacteria engaging in decomposing stuff in it. When those bacteria are exposed to sunlight and oxygen, they die. And when they die, this the urine becomes more or less clean, biologically clean. They use that to irrigate a vegetable garden. Okay. The solid waste, solid human waste, along with kitchen waste, is taken to something called a biodigester. In a biodigester, both the kitchen waste and the human waste is mixed. Anaerobic bacteria convert that waste, human waste and kitchen waste, into methane. That methane accumulates in the biodigester and is led by a pipe to the kitchen, where it's connected to the gas burner in the kitchen. And they get fuel for the kitchen from the waste, from the human waste and the kitchen waste from their own building. Now the methane generated is generally not enough, so they have to supplement it with gas cylinders. But the carbon footprint of that facility would be very, very low. I haven't calculated it, but it will be very, very low. They get water from the site. Human waste is disposed on the site. They have solar energy for their energy needs. They have, they get methane, own methane for cooking. And after seeing that this group is getting, this institution is getting a lot of methane from human waste and kitchen waste, in that city, in Trivandrum, neighborhood groups decided. Now, most of the city of Trivandrum is connected to a water-borne sanitation system. So toilets are all connected and all the waste is taken away. But people realize that kitchen waste is going to the landfill, is creating methane, and methane has the greenhouse gas, it's a greenhouse gas with huge impacts. People started getting together in neighborhoods and said, let's have a neighborhood biodigester, neighborhood level biodigester. So people got together, identified a small place, maybe for a group of 100 or 200 houses in a local park. They identified a small place where they could have a biodigester. And every day, people bring all their kitchen waste and put it in the biodigester. And this biodigester is connected by a pipe network to every house in the 100, 200 place. So whoever's putting the kitchen waste is also connected to the biodigester. And this works very well. Reduces the amount of waste that is sent to a landfill, reduces the amount of methane that is released from the landfill into the atmosphere. All the landfills, like whether they are in US, whether they are in India, they are generating a lot of methane, and the methane is going into the atmosphere. So this is one innovation that these middle class people are doing in the city, inspired what the center was doing with their bio-waste. So, how do you get people in lower middle income and low income families in India to start using toilets? One is to have the mayor show up where they're open defecating. Okay? That's one possibility. But this is another possibility. Okay? This is from, I hope this connects to the